Hello everyone, welcome to the course of satellite communication. In today's class, we are going to learn about Kepler's three laws of planetary motion. Okay, so Johannes Kepler developed three laws of planetary motion by carefully observing the behavior of planets in the solar system. Okay, so let's see what are those three laws. Coming to law one. Okay, the law one says the orbit of any smaller body revolving around larger body is always an ellipse with the center of mass of larger body as one of the foci. Okay, so here what we are considering two bodies. One is the smaller body and one is the larger body. Okay, so if you carefully observe over here, this is the larger body. So if you carefully observe over here, okay, so the orbit of any smaller body, here we are considering an Earth as a smaller body, which is revolving around the larger body called Sun. Now, this smaller body, which revolves around the larger body around the Sun, will be in elliptical order. So, like this, this is an elliptical shape. The revolution will be always in an elliptical order. That is one thing. Okay, with what reference it moves in an elliptical order? With the larger body as the foci or the focus. Okay, so this smaller body called Earth takes the reference point or the focus point of larger body called Sun as the point, reference point, and moves around that particular larger body in an elliptical shape. Okay, for example, all planets move around the sun in elliptical orbits. Okay, elliptical orbits having the sun, this particular sun, as the foci point or the focus point. Okay, with the reference of a larger body called sun, all the smaller bodies, okay, will be moving with respect to an elliptical orbit in elliptical shapes or in an elliptical path. Here, law one only talks about the path, the type of path with which the smaller bodies are traveling around the larger bodies. So, what is the shape of the path which the smaller bodies are traveling around the larger body? Elliptical path. With what reference or what focus or what foci they are moving with respect to the larger bodies as foci. For example, here we have taken sun as a larger body and Earth as a smaller body. Okay, according to our law one, the smaller body called Earth is moving around the larger body called Sun in an elliptical path, making that particular larger body called Sun as a focal point or the foci. Okay, this is law one. Now let's consider law two. Okay, so what does the law two indicates? The orbit of a smaller body sweeps out equal area in equal time intervals. If you see the image over here, there is a smaller body called a planet moving around a larger body called sun. Okay, in an elliptical path. Okay, as you see the planet moving around the sun in an elliptical path, you can see several segments. Okay, so each segment can, let us say, we consider it as 1 month. Okay, so the time taken to complete 1 month by each and every the time taken by the planet to complete that particular time slot will be same. Now, for example, let me take this particular sun. So sun is a larger object over here and we have a planet over here. This planet keeps on moving around this particular sun in an elliptical path or in an elliptical orbit, right? This is according to law one. Okay, now Let us say this particular planet reaches over here. Now the time taken by the planet to move from this point to this point is, let us say, T1. Okay, and the time and the planet keeps on moving like this. Now at the opposite end, the planet reaches. So the opposite end of the sun, the planet reaches. Now let us say the planet is here. The time taken for the planet to travel from this point to this point is, let us say, T2. Now I will say that T1 is equal to T2. How? This is like, you can see, this is a smaller distance, and this we can easily find out this is a larger distance. But how the time period of traveling this path and this path will be equal? Whenever the planet reaches the sun, or whenever the planet is nearer to the sun, the speed or velocity of the planet will be increased such that it can travel more distance within a shorter period. Now, whenever the planet comes far away from the sun, what happens? Means the speed or velocity of that particular planet decreases. That means it can travel only up to a small portion of path, okay, with some time period. Now, the time taken for the planet to cover any part in the elliptical path. So this can be this part, can be this part, can be this part, can be this part. Okay. So as it is moving with respect to the planet position, with respect to the sun, the speed of the planet keeps on changing. Okay. Such that ultimately what happens is the distance traveled by all these segments, or the time taken to travel by all these segments which you see here, okay, time taken by the planet to complete all these segments will be equal. So the orbit of a smaller body sweeps out equal area in equal time intervals, not with different time intervals. Okay, ఎంత area అయినా ఉండనివ్వండి. Okay, whenever it is moving in this particular elliptical orbit, the time taken or the time intervals between each segments or from path to path will be always same. That is law 2. Why? Because whenever this particular planet reaches the sun or nearer the sun, the velocity or the speed of the planet will be more compared to the planet whenever it is away from the sun. Okay, that is what happens. Now let's see law 3. Coming to the law 3. So let's first see what is this particular law 3. It can be defined in various forms, but the meaning is same. Okay, now the square of the period of revolution, here the square of the period of revolution of a smaller body we have considered, right? A smaller body called Earth is moving in an elliptical path, okay, around the sun, where sun is considered as the larger body, right? Now, whenever an Earth or a smaller body completes one revolution, or we can also consider the time taken by a smaller body called Earth to complete one revolution, let us consider it as T. Okay, now the square of the period of revolution of a smaller body, the square of the period means time taken by the smaller body for one revolution. But here what we are doing, we are considering square of the time period. So we can consider it as T square. Okay. Okay. Body about the larger body equals to constant multiplied by the third power of semi-major axis. So it should be equal to constant multiplied by the third power. So with power 3. For what? For semi-major axis of the orbital ellipse. Semi-major axis of the orbital ellipse means I will explain you right now. Now let us consider a smaller object or smaller body called Earth is traveling around the elliptical path around a larger object called Sun. Okay. Now, you know the elliptical path, right? This is defined right now as the Earth is moving around the Sun. Now, segment this particular elliptical path into 4. This is one and this is another half. Okay. Now, consider one length, okay, from the midpoint of this particular segment till the end or boundary of the elliptical orbit. Okay. So this particular distance is considered as A. Now, this A is nothing but the length of semi-major axis. That is what we are talking about. Okay. It is nothing but it is equal to constant multiplied by the third power of semi-major axis. What is our semi-major axis here? The distance from the midpoint towards the boundary of this particular elliptical path, which we are considering it as A. So, third multiplied by the third power means of semi-major axis means we can consider it as A cube. With what we are equating this A cube with the square of the time period of revolution of smaller body. Okay, so the time period of a smaller body is nothing but T. Square of it means T square. It is equal to constant multiplied by the third power of what? Semi-major axis. Semi-major axis is nothing but from midpoint to the boundary or the edge of the elliptical orbit with respect to the reference we have taken. So it is nothing but A cube. So T square is always equal to A cube. Okay, or you can also consider T square is always proportional to A cube, where T square is the time period of a revolution with respect to square, and A is the semi-major axis with respect to the elliptical path. Okay, and that is proportional to the third power of the elliptical orbital ellipse. Okay, now let's consider within some other definition. Same meaning, same concept. The square of time period of orbiting around the sun is proportionate to the cube of distance from the sun. Okay, now let us consider it is this one same thing in the another manner. The square of time period. So the square of time period of orbiting around the sun, which is orbiting the smaller object is smaller bodies orbiting around the sun. So the square of time period means again T square. Okay, it is proportionate to what? The cube of distance from the sun. Cube of distance from the sun means, so our smaller body is, okay, with reference to this particular larger body, okay, can be considered as radius R, or you can consider as radius R. That is nothing but with reference to the distance from the sun, distance from the larger body to the smaller body, that we are considering it as a radius R. So this particular radius R with respect to cube is proportionate to square of the time period of the smaller body to complete the revolution. So square means T square. So T square is proportional to R cube, where T is the time period, okay, which is orbiting around the sun or revolution, and R is the radius or the distance, okay, from between the smaller body and the larger body. Okay, so this is how we calculate or how we relate this particular time period with respect to revolution as well as semi-major axis or the distance from the sun with respect to radius. Okay, you can consider any of these two formulas. T square is proportional to A cube with respect to semi-major axis. T square is proportional to R cube with respect to the radius between the sun and the any planet. Okay, this is the third law.